Good. So, as you all know, it's our webinar number 8 for this series, and today we will be discussing how to work on Microbit on Tinkercad. So let me first remind you by something very important, that in ICT and in science nowadays, we can divide this education journey into many sections. The main parts are coding, algorithm, robotics, microcontrollers, database. So these are the main topics related to ICT, if you want. And when we talk about microcontrollers and how to convince students and you teachers to start this experience with your students, even if you don't have enough background in electronics, like I did since like 5 or 6 years ago from now. I was afraid, really, it was difficult for me to start those electronic definitions and concepts and skills, but slowly you can arrive, and with our support, of course, it will be easy for you. So when we talk microcontroller, you have to convince your students that any electronic or electrical or mechanical device nowadays is monitored or is managed by a microcontroller. The lift, the air condition, the washing machine, the fridge, the cars, all are controlled by a microcontroller. And to convince more what is a microcontroller and why we have to learn microcontrollers, you have to tell them, since all those electronic components and robots and cars and machines in factories does include microcontroller chip in order to control all the component of this machine, let's say. So they have to know how it works and from what it is made. And as you know, since we did previously Arduino training, I remind you that Arduino, it is #1 worldwide in teaching students microcontrollers. But the problem with microcontroller Arduino is that there is no items or input-output device built in, except the LED number 13. And you remember last time we did a small experience with the LED built in on the board, the LED 13. So educators and schools trying to introduce microcontroller Arduino for grades lower than grade 10, it was like an impossible mission for them, since there is a big time consuming to build the minimum, a LED with a resistor or a push button, and then after to pass to the programming or the coding section. That's why Arduino, really, it was impossible to give it for the grades lower than grade 10. But nowadays, with Tinkercad, if you remember last week, with Tinkercad, it is possible, since we have this simulator of the board, that we can make all the construction of the circuit and to program it and to see it like if it is real. Okay, And since now we are on online distance learning, I believe it is the perfect timing and the perfect to introduce them the Arduino with Tinkercad. By introducing the Microbit, the Microbit, which is a microcontroller, but the idea of this Microbit, as we are seeing on our screen, that it contains two push buttons, so we don't have to integrate push buttons like we did in Arduino. We have a screen formed of 25 LEDs where we can display messages, computing results, text, any kind of information. We can display it on this screen. We have an accelerometer and a temperature sensor and a light sensor and a shake sensor. So you have 4 sensors, 2 push buttons, and a screen built in all in this Microbit. Okay, and of course you have digital pins down here. If you want to go ahead and to develop more and more applications with this Microbit, you can do it. Now, education, if we talk education, and I believe you know very well that we cannot give one product for 7 years. I mean, we cannot start teaching, let's say, small basic in grade 7 till grade 12, or Python from grade 7 till grade 12. Students will be bored. And exact same for the microcontrollers. That's why in our curriculum right-click, we decided to divide the microcontroller chapter or skills into 2 parts. From grade 4, 5, 6, you have to deal with the Microbit, since it is easier for students to manipulate this microcontroller, where there is push button, and we'll see it during this webinar. And 10, 11, 12, we are dealing with the Arduino board. Now you will tell me, what about 7, 8, 9? Actually, for the time being in our curriculum, there is no microcontrollers in our curriculum, but for the coming September academic year, in few months, we are developing an extra curriculum to fit or to add the microcontrollers for grade 7, 8, 9 with the Arduino board, but virtually on Tinkercad, since students are not prepared to make the circuit, the hardware circuit. They will make it virtually. They will understand the code as we did last time. They will build on-screen sensors and push button and LEDs. And after, once they arrive to grade 10, they will find the Arduino hardware really not a big task to manage, since they are prepared from 7 and 8 and 9. So as an introduction, I believe, and you have to believe, that microcontroller is a must. We cannot put it away. We have to take it into consideration and seriously to start thinking about how to implement it. If you are using our curriculum right-click, next year in the new books, grade 4, 5, and 6, you will see a chapter manipulating the Arduino board with algorithm, with projects, in order to start making kids thinking about what is a microcontroller and how it works and how to control it. So like this, we will be preparing our student for this kind of projects. So as you know, Tinkercad that we worked on Monday, and we manipulate the Arduino. Today we will be manipulating the Microbit board. It will be almost the same manipulation, more or less. I will show you the difference between how to work on Tinkercad using Microbit or Arduino, okay? And I'll show you the other options of software to manipulate this board. First, you have to know that I will not be showing a PowerPoint, since same introductory slides for the previous webinars done. So I will be showing you directly some. First of all, you have to. Sorry, can you turn off your mic, لو سمحتوا? Please, can you turn off your mic? Okay. So first of all, between brackets, maybe if you go on internet and you try to search for microcontrollers, maybe you will find other than Arduino and Microbit. This is for sure. But when you see that big companies like Microsoft, like Scratch, are dealing, or even like Lego, are dealing with the Microbit, you can conclude that it is one of the best in the educational market. Please do remember that Microbit was developed like 5, 6, 7 years ago. I forget exactly which year, by the BBC in London, Great Britain, and it was distributed for all the students in the United Kingdom for just £1, in order to promote coding for the students in all the kingdom. Nowadays, you can find it on AliExpress or on souk.com like for $10. It's not really expensive, it's worth it. And when you see that companies like Microsoft and Scratch are integrating this module, and they are developing software to deal with the Microbit, believe me, don't think about finding other microcontrollers than the Microbit, okay? And this is the solution for you for lower grades, starting from grade 3 and up. First of all, softwares you can find. You have an application that you can download on your computer. Can you see now the application?
Yes.
Okay, this application is offline. You find it easily on Google. You can download it, and to work on it offline, no need for internet connection. Okay, it's the Make Code. Next week, I will be presenting this application. It is made by Microsoft. And Make Code is also available for the robot EV3. I think next week on Monday, we'll be dealing with Make Code to discover how to deal with the Microbit and the robot EV3. It's not for today. So the first option is to download the application. Second option, like you see here on your screen, you have the makecode.microbit.org, where students are not obliged to download the application in case they are working on a tablet or on their phone or on a Mac. Okay, I don't know if the offline version is available for Mac. I believe it is, but just in case, so you don't have any problem or excuses from students saying that I don't have the software. you can send them the link and they can explore it online. So I showed you the two options of make code, the offline version and the online version. Now I'll be showing you, as you know, the Tinkercad online version for Microbit. So now you see Tinkercad, no?
Yes.
Okay, good. So I will be selecting the circuit part. Next week we'll be dealing with the 3D design and the code block. But for today, I will be selecting the circuit part. I will be clicking on the new circuit part. To create a new design. Okay. And by selecting the Microbit board, okay, you will start your journey in encoding this board. So you have to know that you can start working, and this is what you should do, especially with lower grades. I mean for grade 3, 4, 5, and 6. Of course, you are not asked to move sensors and breadboard and push buttons and LED in order to make a circuit. You will be making something for higher grades for this reason. So you will be starting with the board, just the board, since it's built in with push button screens and sensors. And while clicking on the code section, you will notice that you don't have the option as we did for the Arduino, just to switch between block and text or even text. You remember last Monday, no?
Yes.
Okay, so here for the Microbit, you don't have the option for the text code. And I believe you know why, because it's dedicated for lower grades, no? Excellent. So what we can explore in the different categories of the blocks. We have the basic blocks that maybe we are using frequently. We have the output blocks. I will go through each section, through each category once I finish the presentation of the different categories. So I have the output, I have the input, I have the control, I have the math, and I have the variables. So if you see from the 6 categories I showed you right now, that you can start building simple projects with your students, very simple, very basic. And then after you can go through advanced or intermediate projects, depends on the grades you are dealing with, okay, and how much you have time and you are dedicated to do it with your students. So I will be showing or starting with the basic category. The blocks are to clear the screen, to show a specific icon on the screen of the LEDs I have on the board. I can show LEDs, the 25 LEDs. I can draw a specific shape on this LED. I have the block show numbers, show string, and plot bar graph of 0 up to 0. The control in the basic, I have the weight, if the push button A is pressed or the B is pressed or the 2 buttons are pressed, on shake, and on pin 0 if it's pressed or no. It is a little bit advanced. On the output device, I will be showing again the clear screen, the plot, the unplot, the show number, show icon, show number, show string. I will not list all of them, but you can see the blocks that you have in front of you. We will explore them with project. The input will be read digital from pin 0. As you can see, it's pin 0, it's pin 1, pin 3, the 3-volt pin, 3.3 volt, and the ground. I remind you that the Arduino board, we have like 13 digital pin. Here on this board, I have only 3 digital pins, because we believe that with Microbit, we are dealing with basic projects, not real complicated projects. Okay, so 3 digital pins are more than enough in order to make projects with the Microbit board. I will move to the control category, where I have by default on any project I create the on start and the forever loop. I have the wait, the repeat, I have the repeat while or until, and I can insert inside the condition. I can replace the condition. I have the if statement. I have the if else statement. So you can see that all the structured programming blocks are here. And if you make a comparison with Scratch, it's the same almost. So imagine when you are working with your students a little bit with Scratch, then you move to Microbit, you go to the make code for robot. So I believe you are developing a brain where students can see many languages, many product, and I believe with my experience with students that in this way we can have a student with a well done brain. So I will continue with the control. As we said, we have the if else, the math. You have all the blocks to manipulate math operation, the comparison, the pick number, the absolute of, the round off, and so on. And of course, we have the section variables to go in an advanced programming. Now I will start creating basic project. Say on the forever loop, okay, I will be inserting, let's say, the show let's block. Then I will make it wait for 1 second. Then from the output block, I will show the icon smiley face, and then I will make it wait for. I will make it wait for also one second, and then I will illuminate those LEDs. Okay, by clicking on the start simulation, look how the LEDs are changing by each second. Okay, directly on the screen, you can see that there is the simulator displayed, where you can, if you add a block to shake, look how you can control it. It's the vibration, it's the shaking for a long duration. Okay, and you can make it by moving right or left if you have, let's say, a specific game. So you can control if you turn left, right, and so on. You have the temperature bar, where you can modify the value of the temperature in order to see the result of the coding. and the lighting bar, which is in percentage. Of course, you have the push buttons, A and B, and here you have the push button AB at the same time. Okay, so once you click on the run start simulation, you will have all the details with the simulator, that you can manipulate it as virtual, since you don't have it in real in front of you. Now I will start showing you, let's say, from the control. We'll start making the control. Okay, I will start by moving the, let me see, all day we are on the screen of, okay, so on button A, okay, and on button, I will make on button B, and here we started dealing with algorithm and programming with students. So every time you have to give them a specific project, you will be dealing with them by asking them a specific algorithm. Let's say, let us do on the Microbit a project that allows us to, for example, if we click on the button A to do such instruction, if we click on button B, if the temperature is higher than, if the light is less than. So all the conditions that you can deal with, and here the students has to manipulate. So if I click on button A, I'll be showing, let's say, the smiley face. And if I'm clicking on button B, I will be showing the heart, let's say. Okay, I will start the simulation. And if I click on A, it's the smiley face. If I click on B, it will be the heart. I'm showing you simple manipulation to tell you that it's not a big issue to work with or to deal with lower grades like 4, 5, 6, 4, 5, 6. It will be like simple manipulation, believing that we can go through advanced functions, and I will be showing you right now some of the manipulation. So I'll be building the project, for example, to see if the temperature is higher than 30 or lower than 30. Okay, so in the forever loop, I will be moving the block if else. Okay, from the math category block, I will be moving the comparison block, the green one, as you can see here, and I will insert it in the condition. And I will set the condition to greater than, let's say, 30. Okay. And here I have to insert, instead of 1, I have to insert the input block that read the temperature. So I'll have to go to the input section, and from the input section, I'll be moving, as you can see here, the temperature sensor or the level sensor. So by moving the temperature sensor and by displaying, let's say, I will be moving the show string hot, or I will be moving, if it's less than 30, cool weather. Okay, so with this simple program, okay, what you are dealing with your students, first of all, the loop forever, the idea of the if condition, the if else, how to build the condition by importing the block of the temperature sensor, and by setting the condition and displaying the appropriate message. Okay, so if I click on the start, as you can see now, the temperature is set to 27. It is showing cool. So if I set it to 30 or to 40, as you can see, it is hot. With those simple manipulations, okay, believe me, you are motivating your students in order to go through and link many skills at the same time in a small project. Okay, and maybe you will ask yourself, how can we evaluate students while dealing those projects? You can easily, even by showing you real projects. I will show you in grade, today my students in grade 6, we started working with the Tinkercad 3D models, and today I did them a small assessment. Can you see Photoshop now?
Yes.
Okay, so as you can see, look at the production of your students, of my students, sorry. So I asked them to show me the project. I took a screen, and then after I evaluate the result. Look here those different projects. It's various projects. It was not made to do just one subject. Okay, so for Microbit, it's the same. You can ask them to work a project online, since Tinkercad will save the project, as you can see on your dashboard. Okay, and if you want to ask them an assessment written or on Google Classroom quiz or something to see if they understand the content, you can create this script or something similar to it, and students have to write, okay, what this script will do if it is executed on the Microbit board. Okay, so is it okay for now?
Yes.
Okay, great. Any questions?
No, sir.
Okay, good. So I will be moving and working with something little bit intermediate to advanced, which is the plot and the unplot block. So the plot block will be the block that illuminate and or turn on and off a specific LED. And as you can see, that this matrix, okay, is formed of 25 LEDs, and for each LED there is a specific coordinates, the X and the Y. Okay, so if I click on start now, you will see that the plot X equals 0, Y equals 0 will be illuminated. Okay, if I want another one to be so I will put here the weight, for example. Okay, and then after let's say 4, and then I will start. Then after, as you can see, and from this example, we can see that the first LED has the X and Y 0, 0, 1, 2, 3, 4, 1, 2, 3, 4, and the last one on the right bottom, the address is 4, 4. So and if you want to unplot or to turn off, you can go and click on the unplot 0, 0, and like this, you can see that so it's really quick since there is. Okay, so now I will run it again. Okay, so from these two blocks, the plot and unplot, so from those two blocks, plot and unplot, you can imagine a series of exercises that can cover many sessions, especially with students in grade 6, for example, where you will be using variables. As you can see here in the plot XY block, there is a rounded space where I can insert actually a value or a variable. Okay, so I will show you an exercise, and believe me, it will be very exciting for students. And if you can reach this kind of manipulation, you will be satisfied, and the students will be really satisfied. Is by creating a new variable called x. Okay, on the beginning on the launching of the program, on the start block, I will be setting the variable x to 0. Okay, I will be in the control block, I will repeat 4 times. Okay, I will be moving from the output plot 0, 0, 0, and in the x, instead of keeping it as a constant, I will be moving the variable x. Okay, I will be waiting for 1 second, then I will be incrementing the variable by 1, changing the x value by 1. So it's like x equal x plus 1 for 4 times. Okay, I will be trying this program to see if it's working or not. 1, 2, 3, 4, 5. Okay, so the program illuminate the 5 LEDs, so it is working and working. Okay, if you want to make more control, you can type here 0 1 2 3 4. صحيح، فإذا هيدي بتكون 4. If you want to add more control, you can add the if block. I'm trying with you. It's my first time, huh? The if block, and by saying if the variable x is equal to 4, then display a smiley face. Okay, I will try it. Hope it will be good. 2, 3, 4, and it's smiley face. Okay, is it okay?
Yes.
Okay, so I'll try to send you, knowing that in our curriculum for next year, it is well done for like 6 to 8 periods, I think, for Microbit. It's well done, the scope and sequence. And if you want to discover it right now, before from now, I can send you the PDF file of this section in order to take an idea about how to divide the scope and sequence for over the 3 years. Now I will be moving to something a little bit advanced, which is the just to see if I missed something here. Okay, the input, I gave you an example of reading the temperature sensor, so it's the same for the light sensor. The control, we saw the repeat, the if, the else, the math, we saw a few of them, and the variable, how to manipulate. So now I will be showing you how, if you want to add, like Arduino, an external LED. Okay, is it possible with Tinkercad? Of course, yes. Look how I will be doing it. I will be moving a breadboard. Okay, I will be linking the ground pin as I did for the Arduino. Okay, I will be linking the digital pin to for example, let's say this column. It will be the same as the Arduino that we did last on Monday. And believe me, since with Microbit it is displayed in a clear way, and students will like it more, kids more than the Arduino, since it's impossible to manage it with Arduino. So indirectly, you are preparing your students to deal with the Arduino later on in a clear way. So I will be adding a LED. I will put the LED here, as you can see. Here is the anode, the plus, and here is the cathode. Okay, I will be linking the minus here to this column. So my circuit is done. What I need now is to see how can I illuminate this LED. So the concept of coding is the same. I will be deleting all this. So I will be taking the output. Okay, and since it is an external output linked to the digital pin 2, so I will be moving digital right pin, and I will select pin number 2 to high. I will be asking to wait for 1 second. And then after, I will be a digital pin right pin 2. I will set it to what? Too low. Okay, I will launch my my program, and as you can see, my LED is blinking. Okay, and I have a small warning here saying that the LED has to be protected by a sensor, by a resistor. But of course, here, if you are dealing with small kids, like for grades 4, 5, 6, they will not understand what is sensor. I'm explaining this to you, of course, to show you that the same concept is available for Arduino, and at the same time for the Microbit. Okay, so And here all the programming concepts are available by, like if you want adding variables, if you want to add a buzzer, I can add it as simple. So I will be stopping it. Look here at the buzzer or the piezo buzzer. I will be moving to it and put it, let's say here. Okay, the negative, it's taken from here, and the positive will be taken from digital pin 1. Okay, so like in Arduino, I'm building my project in Microbit in a simple way. And regarding the coding, I will be adding, let's say, the digital output. Look how I will make it. The digital write pin 0, pin 1. It's on pin 1 to high, and then digital write on pin 1 will be low. So let us see what will be the result. Can you hear the voice of the piezo?
No.
Let us try now. Now.
Yes.
Okay.
Yes.
Okay. So, do you believe that working with kids for those projects, it will be an excitement for them, and it will be challenging for them more than save on a USB or format the paragraph or I don't know what? Huh? Is it challenging working with this technology with your students?
Yes, I think it is. They like to do things with their hands, like in Lego. They like to put parts with each other and then see the result at the end. So they will be excited. Yes.
Okay, and since you are working according to a curriculum tested, and it is linked through many levels, so you will be sure that the message will be transmitted and will arrive to students without any failure or without any problem. Okay, so all the components that are here for hardware, like the ultrasonic or the photoresistor or the motor, will be available. But if we want to be practical, I don't believe that those advanced electronic component, will be manipulated with kids for lower grades. That's why I believe, in order to terminate this webinar, that the microbit is made for lower grades in order to introduce the idea of microcontrollers. With make code, you have the basic manipulation that you can do with your students, like I've did here in Tinkercad, by manipulating the push button, the LEDs, the temperature sensor, the while loop, the if loop. All those manipulation could be done with make code and with Tinkercad. In Tinkercad, the advantage is that you can add electronic component. I mean, if you want to go further, you can go with Tinkercad, but you have to take care that the maximum you can do with your students is by inserting on the breadboard a LED or a buzzer, not more, since students will not understand and it will be difficult for them to manage those like the ultrasonic or the temperature sensor and other sensors. Once we arrive to this point, we have to move to Arduino. Okay. I'm trying to see. I've prepared a plan to see if I covered all the points. So defining a microcontroller, and of course here I missed the point that the working with microcontrollers is in direct link with Internet of Things, with artificial intelligence and building STEAM project. Educational microcontrollers, as we said, are Arduino and Microbit. The difference between Arduino and Microbit is that on the Microbit, I have push buttons, screen, and sensors. On the Arduino, I don't have. Teaching, sorry, your mic off, please. Sorry, your mic off, your mic off. Teaching Microbit should start in grade 4. And the software available are online and offline. And I've tried to show you some manipulation. Of course, I did not cover all the examples and the manipulation we can do with our students, but I've showed you two kinds of manipulation by showing you how to insert the breadboard with the LED and the buzzer and how to program them, okay, and how to manipulate the plot and plot and the push button with the while and the if. So I'd like to hear from you if it was clear, if you find it doable with your students, or it is difficult, it's interesting or no. So I'd like to hear, or by WhatsApp or by right now, I'm ready. And don't forget to send me your email and your full name in order to send you the certificate of participation as usual.